yeah, I probably should tell a bit more about my background. I'm not sure who've been already to parents' meeting already know, but I have background in neuroscience. I used to be a clinical neuropsychologist in the past. And what I'm trying to do in the math classes is to bring my neuropsychological background into teaching children. We just using math as a as a subject for enhancing different cognitive skills, which would be then used by them and applied in all the subjects. And that's the joy of math and teaching math. Anyway, so our overall strategy for our classes is that we would like to develop things that maybe not so much developed at school. So of course we're using some curricular themes, but we're trying to come to them from slightly different points. So we're trying to add to curriculum and also reinforce it, but always to bring something new into something that maybe children haven't yet experienced at school. Also, we pay a lot of attention to make the experience sort of felt experience, so they would be able not just to memorize and remember just another set of abstract knowledge, but to make them discover things either by, when they're doing things by hands, when they're creating something, which is enhancing their constructive skills, but at the same time, we would like them to make their own discoveries. And I will give you an examples how we do it later. We also like to use as much as possible graphic methods in problem solving, because we feel that the tendency in school is to do everything in mind rather than on paper. And, school emphasizing of, and I feel it from children when they come, that they're trying to use paper as little as possible. We would like to break this pattern and befriend them with the paper. So paper could be their real tool and a thinking method, and then they would be able to talk to themselves by using paper and observe their own thinking process, and then refer to their own thinking process. They see their maybe different attempts at solving a particular problem. Also, we would like very much children to be able to understand the idea of clues, use the clues themselves, know what would be a good clue or hint, creating their own problems, so they would really understand how problem works, what do you need to have to make a good problem, and how then you solve it. So by creating their own problems, however simple they are, it gives them a freer understanding of what makes a good mathematical problem, and then what teachers expect from them when they present it with the problem. They would better understand how it was made and what somebody wants from them if they try to make their own. And and we try in the class to use a lot of discussions. So we would really like them to be able to explain their thinking, discuss, find each other errors, and then discuss how these errors come about and what you need to be attentive to avoid them in the future. Okay, so since I already told them our main principles, I'll just quickly run you through the themes that we did. We really try our best to reinforce school themes but we would always try to bring as much problem solving as we can, even in any small or simple topic. So as I told you, we were trying to bring different graphic methods. And we started with something that's familiar to children, especially we have lots of children in our Hampstead branch who just new to our classes. So we really wanted to start with something that's familiar to them. So they would feel more at home in our classes, so we wouldn't surprise them with something very unusual, because it takes time to grow into our way of presenting and discussing problems. So we started with attributes and charts, and we run through different ways of graphic representations of data. And we also discussed that even such a simple Venn diagram with just two circles could give you lots of different questions to ask. And so we practiced that in the class to see how many questions we could ask about to a simple group of objects. Then we did a lesson on bar charts and different problems around that. And also we were trying to scale them. Then we touched on fractions, and we did it in a different ways, starting from cutting more traditional things like cutting papers in different fractions to problem solving and creating our own worded problems using this problem with the fish and fish tank. Then we developed this theme talking about, I'd really like just to show this interesting example of the creating problem using these houses and different clues that one could give, and children would bring their own different problems, and then we would discuss what's the minimum number of clues that we need for the problem, when it is excessive and the problem is too simple, because you already know everything if you just carefully read until the end, and what would be enough and what would make problem difficult. So there was a really interesting experience with different age groups, because it's simple. At the same time, they had to think how they give out information to others to make it an interesting problem. We had variety of problems using this Danish set. And at the screen, you will see this chain made of shapes that only have one characteristic in common with each other. So that's was the most difficult. So I managed to photograph it. But usually our classes are very intense. So I regret now making presentations that I not often have a chance to photograph, being absorbed in the process. Let me see. What would be the next? Yeah, we touched on classical theme of odd and even numbers. And again, we did a lot so they would really feel more about properties of odd and even numbers. And I was pleased that even children as old as 8, who already seemed to know a lot, still made some discoveries in the class about the properties of addition or multiplication of odd and even numbers. They of course know times table and of course know many things, but they were able to feel and to discover themselves the principles of operating with odd and even numbers. And that was quite nice to see. Then we made some interesting discoveries about angles and triangles. Talking of felt experience, when it's possible, we try to create something physical. For example, with the angles, we made a little gymnastics to help children remember, starting from acute angle like this, and going all the way to the full angle, connecting hands at the back. So this sort of really felt experience make it more fun and interesting and more connected. These sort of abstract names and ideas make it more connected. We also discussed why a right angle is so important, you know, how people, why it's so easy for us to see it. You know, we talked about gravitation. So we made these connections of making these abstract ideas more relevant to their personal experience. And also, you know, we didn't talk about 180 degrees, but we sort of, if you can see from the pictures, we proved that the sum of all angles, if you put 3 angles together, they will make a straight line. So later, it was a big surprise. But later, when they will come across this topic of the sum of the angles of triangles, it would be already there. That's what I call felt experience. They're known for them and felt, you know, this discovery hopefully will stay with them for longer than just a week of the class. So that's what very fruitful theme of triangles and geometry that hopefully will be then further developed in the next classes of math circles by my colleagues. So let me see what else. Yeah, and even when we discuss a simple subject like shapes, and in this case triangles, we would always like to add different dimensions and also to talk about strategies and ways of checking. For example, in this case, the idea was to count all triangles. And it seems simple, but then the next question that comes up, how would you check that you really counted all? And how can you prove that you really counted all? And then you need to have a system. And then we would, first of all, they would try different ways, and then we would discuss about the system of checking if you did everything right or not. How do you check? How could you make sure that you check correctly? And that's this sort of problems is a good example of multidimensional, well, let's say, of many, many different things that you could do with the simple problem, because then you could also discuss what would happen if you add another line. By what does it do to number of triangles, how they increase, and why it happens. So later in the year, we probably would play more around these things. And come at this type of problems from different sides. It doesn't have to be triangles next time. It could be something completely different, which would have the same principle. So that's what we quite often try to do in our classes, is just to link the same concept through completely different visual representation. So in this case, it's triangles and we're adding another line. Another day, it could be pizza and we're adding another ingredient. And we'll see what it does to varieties of pizzas that could be created. In another problem, it could be something completely different. Friends meeting each other, and another comes and handshakes. And so basically it would be the same principle coming through different problems, but we wouldn't announce it. And we will see if they able to make this connection themselves, that these completely different problems have something in common. So that's what we're trying to do overall, just to put this thread through the different classes. Sometimes sequentially, like every next class would have something from the previous hidden invisibly, or sometimes it will be like, one in every 2 or 3 classes where we would introduce the same theme to see if this new way of thinking, new pattern, somehow registered already, or they have. If not, it's okay. They will have to rediscover it every time again until this process will become quicker and easier. Let me, we also played a bit with 2D shapes and 3D shapes, thinking how we could, and also introduced this isometric paper. And isometric paper is a great thing, and children who like to draw, they really got very interested, absorbed in it. And I think just by having it around and being able to draw on it and create different patterns, children could make a lot of discoveries. But in this case, our question was, can we make pyramids from all, we know that a pyramid would be made of 4 triangles. So would it be possible to make a pyramid out of any of these 4 triangles put together or not? And possibly you had at home the outcome of our work. Yeah, and there was a little fun at the end with different arithmetic and construction using papers. So I'm sure that some pieces arrived safely home. So anyway, that's what we did this term. And hopefully we will, next term we'll develop further in that direction with more problem solving, more unusual things. As children already know us more, we know them. So they're getting used to doing slightly unusual math. And they already used not to maybe having numbers all the time, like that math is more than just numbers. So, so I'm looking forward to having more fun next time.